This is the Mad Scientist back in the game on January 21st, 2012, conducting Trial 1, Test 4.
And today we're going to measure the mass of the egg. As you can see right here, we measured the mass earlier, and the mass of the egg was 58.1 grams before the crash. And as you can see, we already measured it. So now we're going to conduct our trial, Test 4.
So as my partner does the crash, I'll be pointing the camera towards the calculator so that you can see how the graph interprets the data.
And
Ready? 1, 2, 3. 1, 2, 3. So as you can see, this is how the graph interpreted the data, and we found that force was negative 2.790 Newton. And this is the graph that was interpreted by the calculator.
And as you can see, there's some distance left,
which means that the force was spread out over a certain amount of time. So now we will be examining the egg.
And as you can see, there is no cracks in front of the egg at all. And now to the back of the egg, there's no cracks in it at all too.
So now we will be measuring the mass of the egg after the crash.
As you can see, the mass of the egg is 58.0 grams right after the crash, and it decreased by 1 milligram. And so we can see that it decreased. And now my friend or partner is going to explain to you about velocity and acceleration of
So if we look right here at test 4 for our trial 1, we can see that 18 centimeters represents the displacement and 0.86 centimeters represent 0.86 seconds represents the elapsed time of the crash. Then once we divide those two, we get 20.9 centimeters per second. Then our acceleration is equal to 20.9 centimeters per second, which is the velocity, divided by 0.86, which is the time of acceleration. When we divide those, we get 24.3 centimeters per second. So that concludes test 4 of trial 1, which was silly putty. This is the Mad Scientist. Thank you very much.